Good afternoon, students. Today's topic is page replacement algorithm. In the class, we already learned about what is page and frame. We know that in main memory, we'll call the storage space as frames, and in the secondary storage, we call it as pages. So when a process wants to run in main memory as well as a CPU, if we want to run the process, it should be run by the CPU. Okay, so to run the process in CPU, that should be present in the main memory. That is the basic concept. So because of the less capacity of main memory, each process is stored into the secondary storage. Whenever it needs, it would be allocated into the main memory. But in some cases, the size of the process is very big compared to the main memory itself. Okay, sometimes 2 KB if main memory size means a process size maybe 2.5 KB. So we couldn't able to allocate the entire process into main memory. Okay, so that's why we need to utilize the main memory or the memory in a very proper manner. Then only we can say our operating system is a good one. Okay, so to utilize the memory space properly and efficiently, we are using an algorithm called as page or frame replacement algorithm. Okay, so when a process comes into main memory, it should be stored into number of frames. Okay, so if you want to store a particular process, we need to find some free space of frame. Okay, so if I want to pour some water in a water bottle, there should be some of the empty space. Okay, then only I can able to pour a water into that. If it's completely filled, I couldn't able to fill some new water. Okay, the same concept. If we want to keep on process in main memory, we need to find some free space. If there is no free space, we need to remove particular process from main memory into backing store. Okay, that is the basic concept. In this place, we are using this page replacement algorithm. Okay, so totally 3 page replacement algorithms are used. First in, first out page replacement algorithm, optimal page replacement algorithm, and least recently used algorithm. We'll see one by one. Okay, it's a very interesting problem to solve. So the first one is first in, first out algorithm. Okay. So the main aim of this page replacement algorithm is the page fault or rate of page fault should be minimized. Okay, that is the main thing we need to concentrate when we are doing a page replacement algorithm. So this is the first algorithm we are going to do, first in, first out. Okay, so these are the reference string given to us. Okay, or consider this are the process number. Okay, we need to keep this process into main memory. Now, the size of the main memory frames given is 3 frames. Only we have 3 compartments. Consider like that. Okay, so in this 3 frames, we need to accommodate this many pages. Okay, this many pages we need to keep into the frame. Okay, so the first concept is first in, first out algorithm. So while you're solving the problem, this reference string as well as frame size also given to you. Sometimes frame size may be 2, it may be 4, whatever. So based upon that, you make the picture. Okay, if it is 4 compartment, you create one more row here. Okay, so here it's given us 3 frames. Okay, so we'll start doing the problem. Okay, so based upon our concept, we have 3 frames. Okay, 1, 2, 3. Okay, so initially you check 7. First number we have a 7. You check here in the frames, 7 is not there. This is called as page fault. Okay, page fault. Page fault. Okay, if a page is already there, that is called as page hit. Okay, our main concept is we need to reduce the page fault. Okay, so we'll solve this problem one by one. So first we are checking whether 7 is already there or not. Okay, 7 is already not present in the memory. So I am keeping the 7 from here. Okay. 7. Okay. The next is again, I am checking whether 0 is present in the main memory or not. So 0 is also not there. We have 3 frames. 0 is also not there. So that is also considered as page fault. Okay. So please take 0. Okay. So 7, 0. Okay. The next is 1. 7, 0. 1. 1 is also not present here. Only 7 and 0 is here. So I am placing 1 here. So that is also comes under page fault. Next is 2. Okay. So our concept is first in, first out. Okay. So now my main memory is filled. I have 701 content in each frame. Okay. So now if I want to place 0 here, 2 here, I need to replace something. Okay, so what is my concept? First in, first out. So who came first? 7. So I am replacing this 7 and placing 2 here. 2, 0, 1. Okay, so here also 2 is not available previously. So that is also comes under page fault. Okay, next is 0. 0. You check the frames. Already it's filled 2, 0, 1. But 0 is already there in the main memory. Okay, so CPU automatically takes the process 0 from here. No need to replace it from the hard disk. Okay, so 0 is already there. That is called as page hit. Okay, so 0 is over. Next is 3. Come to 3. Okay, we have 3 frames. I'm checking. 3 is also not there. So I need to replace something. Already I replaced 7 and placed 2. So what is the next one? My concept is first in, first service. So I'm placing 2. I'm replacing 0 and placing 3 here. 3, 1. Okay. Is that clear? So 3 is over. So 3 is also not available. So that also comes under page fault. Okay. After that. Next is 0. 0 is also not there. Already I replaced 2 and 3. So I am now replacing 1 here. So 0. Okay. 0 is not already there. So that is also comes under page fault. Next 4. 4 is also not here. Till this 3 I have replaced. So again I am coming from the first frame. Okay. 0 is over. So 4, 3, 0. So 4 is over. Next I'm taking 2. 2 is also not here. So again page fault. So I'm replacing this 3. So 2, 0. Okay, 2 is over. Next, taking 2. 3. 3 is also not available. So 4, 2, 3. 0 is replaced by 3. Okay, 3 is over. Next is 0. Again I am coming from the first. Okay, I'm replacing 4 by 0. 0, 2, 3. 0 over. Okay, here also page fault. Next is 3. Okay, so you check here 3 is already present. So that is called as page hit. So I don't want to replace 3 is already there. Next is 0. 0 is already present in the main memory. So again, I don't want to replace 0. This is over. Okay. Next is 3. 3 is already present in the memory. So this is also over. That is comes under page hit. Next is 2. 2 is there. So 2 is over. It is also added into the page hit. Now 1 is not present into the main memory. Okay. So till 2, 4, I have replaced. So I am again starting from the second one. So instead of 2, I am placing 1, 3. So here it is page fault. I have 0, 1 and 3. So now we placed 1. Next I am checking 2. 2 is also not there. Page fault occurred. I replaced 3 with 2. Okay. Now you please count and write how much page fault, how many page fault and page hit occurred. Okay, which all are I marked wrong symbol, that is comes under page fault, which means that page is not there in the main memory. We either allocated or replaced. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here the number of page fault is 12. 1, 2, 3, 4, 5. Number of page hit is 5. This is the answer for the first FIFO, page replacement algorithm. Okay. Then this is the first one over. Then we come to the next algorithm. So if we are increasing the number of page fault, that is wrong. Okay, not wrong. The operating system efficiency or operating system usage will be get increased. So that is called as adding more frames can cause a page fault. Okay, this concept is called as Belladay's anomaly. Okay, we need to reduce this adding more frames. Okay, that is one concept of this FIFO algorithm. Then the second one is optimal algorithm. Okay, so the concept of optimal algorithm is, so in our first concept FIFO, we replace the pages which is first located in the main memory. Okay, but here what we are doing is we'll check the upcoming frames. Okay, so the operating system will have an analysis and it will make a decision that this may be the frames or process will comes in the next section. Okay, so we are checking the upcoming frames and replacing the frames from that which will not be occur for a longest period of time. That is called as optimal algorithm. Okay, so you can read this line, replace the page that will not be used for a longest period of time. That frame we are replacing. Okay, so again we are going to solve this same. Okay, here also our frame size is 3. So I'm taking 3 compartments. So what is the first one? First use the same concept. First in, first out concept. Okay, 7 is not there. So page fault. So I'm placing 7. 7 over. Next is 0. 0 is not there. Page fault. 7, 0, 1. Sorry. This is not. Won't become. Okay, next 1. 1 is not available, page fault. So 7, 0, 1. 1 is over. Next is 2. I'm checking here. 2 is not available. So I need to replace any one of the frame. So my concept is I want to check which will not be occurred for a longest period of time. Okay. So what is my next frame? 2. Okay. What are the frames already here? 7, 0, 1. So after 2, you check the remaining. Okay. I need to check whether 7, 0 and 1 will occur recently or it will take too long time. Okay. So here 0 is occurring very closer. Okay, after that, 7 is not occurred. Okay, the entire frame 7 is not occurred. 1 is occurred. Okay, so I can by default replace 7 because 7 will not occur. Okay, so instead of 2, 7, I am replacing the 2. So here also page fault because I replaced 7 by 2. Okay, next is 0. 0 is already there. So that is called as page hit. It's over. Next is 3. 3 is not available here. Again, I want to replace any one of the frame with this 3. Okay. In my memory, 201 is available. Okay. I want to replace this with 3. So check 1 is occurring nearer. Then 2 as well as 1. 1. 1 is taking little bit time to enter into this main memory. So I am replacing this 1 by 3. Okay, instead of 1, I am replacing 3. So 3 is over. Okay, next is 0. 0 is already there in the main memory. So it is page hit. Next is 4. 4 is not here. So that is page fault. So I want to replace any one of this with the 4. So please check 203. From this 203, which will occur later? 0. Comparatively, 0 will occur later. Okay, so replace 0 with the 4. Okay, next 2. 2 is already there. So that is comes under page hit. Then 3 is already there, comes under page hit. Okay, then 0 is not there. So there we have a page fault. Already I have 2, 4, 3 in my main memory. I want to replace this by 0. So please check 3 will occur faster, 0 will occur, 4 is not there. So I'm replacing this 4 with 0. Okay, this is done. Okay, next 3. 3 is already there. So page hit, 0 is already there. Again page hit. Okay, next is again 3. 3 is available. So page hit. 2 is available. Page hit. Then 1 is not available. Okay. So I want to check here. I have 2, 0 and 3. 2 will come nearer. 0 will not come. Both 0 and 3. I am replacing the first one. Okay. So here also I have page fall because I couldn't find 1 here. So 2, I'm replacing 0 by 1 and 3 here. Okay. So this is over. Next 2 is available. So it is page hit. Okay. This is the answer for optimal algorithm. Okay. Now you count how many page fault as well as page hit occurs. Okay. Page fault as well as page hit. Page fault is 1, 2, 3, 4, 5, 6, 7, 8. Okay. And the page hit is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so compared to our previous algorithm, in the FAFO, we got 12 and 5. Number of page fault is higher. Okay, for the same problem, when we are applying an optimal algorithm, we got some reduced page fault, 8. Okay, so comparatively, FAFO and optimal is a good one. Okay, then the third algorithm is least recently used algorithm. So in the optimal, what we done, we are replacing the frame which will not occur for a longest period of time. Okay, same concept, but here in LRU, you check which frame already occurred, most frequently occurred frame. Okay, that we are replacing. Okay, so read here, replace the page that has not been used for a most amount of time. Okay, so you are checking the past instead of the future. Okay, so same concept, checking the past things. So which has not been used for a most amount of time, that frame we are replacing. Okay, so again we'll solve this by the problem. Okay, 701. Here also my frame size is 3. So we are drawing with the 3 frame sizes. So 7 is not available. Okay, so I'm taking the 7 here. So this is page fault. Then you know these things. Okay, 7, 0, 1 is not there. So that is also comes under page fault. 7, 0, 1. Then 2. Okay. So 1 over 0, 2. 2 is not here. Again, page fault. So what is my concept? Checking the past things. Okay. Which will occur longest period of time? 7. So I am replacing 7 by 2. Okay. This is over. Next is 0. 0 is already there. So it is page hit. Okay. 3. 3 is not available. So it is page fault. I want to replace. So check the previous strings before 3. 0 is occurred nearer. 2, 1 is occurred just later. Okay, more prior. So I am replacing this 1 with 3. Okay, so this is over. Next 0. 0 is already there, page hit. Next is 4. 4 is not there, page fault. I want to replace. So compare to the previous strings of 4, the 0, 3, 2 is occurred more priorly. So I am replacing this 2 with 4. Okay, 4, 0, 3. Okay, next is 2. 2 is also not there. So again page fault. Okay, so 403. 3 is occurred very earlier. So I am replacing 3 with 2. Next is 3. 3 is also not there. So comparatively, 4 and 2 is nearer. I can replace 0 with the 3. Okay, 4, 3, 2. Okay, this is over. Next is 0. 0 is also not available. So again, I am replacing 4 is clearly occur. 0, 3, 2. This is over. 3 is already there. So it is page hit. 0 is already there. Page hit. Again 3 is there. Page hit. 2 is there. Page hit. 1 is not available. So I want to replace 1. Check 2, 3, 0. So I am replacing 0 by 1, 3 and 2. Okay, here. So the page fault. Next is 2. Page hit 2 is available. Okay, so here you count the number of page fault as well as page hit. Okay, page fault is 3, 4, 5, 6, 7, 8, 9, 10. Hit is 1, 2, 3, 4, 5, 6, 7. That's also 7. Okay, so comparatively for this problem, this optimal is a good one. Okay, for FIFO, we got 12 page fault and optimal 8 page fault. Again, this LRU 10 page fault. Okay, so based upon the priority as well as process, your operating system will choose the best algorithm, either optimal or the LRU algorithm to replace the frames. Okay, thank you.